Today we're going to look at solving equations involving fractions. And this is going to take a little bit of time to develop because when there's fractions involved, things get a lot more complicated. It's not just quite as simple as just getting the x's on one side and getting the numbers on the other side. But what I'm going to go through is go through a question that looks like a division question. It looks like it has division involved in it, and talk about the fractions involved. Then I'll do one with fractions. We're going to try and come up with a method that's going to handle fraction questions in a fairly straightforward manner. So as you're walking through these first two examples with me, be aware that at times it's going to seem like this is impossibly difficult, but hopefully, just to give it away a little longer in the lesson here, I'm going to come up with a great trick for dealing with fractions and equations, okay? So that's what these first two examples are about, is trying to build that great trick. Now, what we've learned so far in solving equations is that what we want to do is inverse operations. We always want to do what's the opposite of there in an effort to dig out the x value, to isolate the x value. So this first question here says x plus 5 over 3 equals negative 15. And there's no reason to think of this as a fraction right here. What we are looking at is x plus 5 divided by 3. The first move is to get rid of divide by 3. So you think, okay, what's the opposite of dividing by 3? And the opposite of dividing by 3 is multiplying by 3. So what I'm going to do is multiply both sides of this equation by 3. I'm going to multiply this side of the equation by 3. And I'm going to multiply this side of the equation by 3. Because the big rule of solving equations is you can do whatever you want to an equation as long as you do the same thing to both sides. So I chose to multiply both sides of this thing by 3. Good things happen on both sides of the equation. On the right side of the equation, 3 times negative 15 is negative 45. Now that's worse than it was before because it's a bigger number, but not really a big deal. It didn't cause us a big problem. Now over here, what happens is this is multiply by 3 and this is divide by 3, so those two things cancel out. When you're multiplying something by 3 and then dividing it by 3, you end up with the same thing. And if that's not clear, take a look at this. If you go 3 times 792 and then divide it by 792. Actually, I want to use the exact same numbers we were doing here. If I take 792 and I multiply it by 3 and then I divide it by 3, you can do this in your head. And if you don't believe me, type it into your calculator for a second. Type in 792 times 3 divided by 3, and you end up with 792. And hopefully when that's done, you go, oh, I get it. If you multiply by something by a number and then divide by that exact same number, those two operations cancel each other out. It's almost like you shouldn't have wasted your time going through the whole operation because those two things cancel out. And that's exactly what happened down here. Is I multiplied by 3 and divided by 3. Those two things canceled out, and life just got a whole lot better. I'm left with x plus 5 equals negative 45. Isn't that nice? Because now it's an equation that doesn't have a division sign in there. And so now I do the opposite of adding 5, which is subtracting 5. And maybe you're a little faster at this now, where you don't have to show all of that in there, and I get x equals negative 50. As a side note, there's an excellent way to check if this works, is I type into my calculator, I just take this x and sub it in as the x here, and I go negative 50 plus 5 divided by 3 as negative 45 divided by 3 equals negative 15, and that is what the right side is, so I know my answer is right. Okay, now I said this lesson was about fractions, not about division, and that whole discussion was about how do I get rid of dividing by 3. The same exact argument could be made if I had described this whole question and said, oh, it's got denominator 3, so I'm going to multiply by 3. So having division versus having a denominator, that conversation is the exact same for both. So at the end of this question, we could say, oh, to get rid of division, we multiply by 3. But to get rid of a denominator of 3, we multiply by 3. Those two sentences are the exact same. So that's lesson 1 of this lesson. The first part of this whole lesson is to get rid of division or a denominator, multiply by what is being divided. Okay? And you saw some questions. Actually, there's probably a question like that in the homework. You're not surprised by all that. But all I've added is this word here, denominator. That's the only thing I've added in that whole example. And that gets us ready for the next example. Take a look at this one. x over 3 plus x over 2 equals 10. It's now got two denominators in there. Now, you can do this question by getting a common denominator. And as I'm doing this, if you get lost in the details, don't worry, because I've got two methods to handle this thing. I'm going to do method 1, which I hope by the end you'll go, okay, I sort of get that. But if you don't, that's okay. I'm going to come over here and do method 2, and I'm hoping that method 2, you're going to go, oh, I get that. I like that. And it's going to be a lot tidier. So don't fret. Don't freak out during method 1, because I'm going to show you something. I don't know if it's better. I really don't know if it's better, but it's smoother. It's definitely smoother. So to be able to handle this question, I've got to get this as one fraction first. So I need a common denominator. The common denominator is 6. So I need the first one over 6 plus the second one over 6 equals 10. And so what, I multiplied this denominator by 2. So it was the denominator 3. I multiplied it by 2 to get 6. So I've got to multiply the numerator by 2, and I get 2x. The second fraction was x over 2. To get it to 6, I had to multiply the denominator by 3, and so I got to multiply the numerator by 3. Now I can add the two fractions. Keep the denominator the same, add the numerators, and now I'm ready to do what I did in the previous questions. The opposite of dividing by 6 is multiply by 6, so I'm going to multiply this side by 6. I'm going to multiply this side by 6. Over here, I get 60. Over here, the 6's cancel. And I get 5x equals 60. The opposite of multiplying by 5 is divide by 5. So I'm going to divide both sides by 5, and I get x equals 12. And maybe all those steps you look at and go, oh, that's great. I totally get all that. And that's a perfectly legitimate method to do the question. But it can be a little bit confusing, all the steps, and certainly the common denominator stuff, especially if your fractions aren't really strong. If your fractions are really strong, you might just do method 1. It's great. But if your fractions aren't very strong, method 2 has some possibilities. The end result of all this was right in this step here. I'm going to write this in red because it's so important. Right here, we multiplied by 6. And what was that 6? Where did that 6 come from? It was the common denominator. And that's the awesome trick I'm going to show you, is that at some point, when you've got multiple fractions in a question, you're going to multiply by the common denominator. So what mathematicians figured out was, you can just do that right at the start. Why not just multiply by the common denominator right off the start and see what that does? So x over 3 plus x over 2 equals 10. And I've spaced that out on purpose. And what I'm going to do is at the start, before I even start, I'm going to look and go, oh, common denominator of 6. I'm going to multiply everything by 6 right off the hop. I'm not even going to wait around. I know that's what's coming anyways. So when I do that, when I multiply 6 times 10 over here, I get the 60, just like I did in the first solution. And in here, I've got to distribute this 6 onto each piece here. And to distribute it, I'm going to have to think of 6 as over 1. Hopefully you remember that from your fraction tricks, is that when you're multiplying a whole number by fractions, you're going to have to put the whole number over 1. And so here I get 6x over 3 plus 6x over 2 equals 60. I multiplied top times top and bottom times bottom in each of those two fractions. And at first glance, you go, that didn't accomplish anything. All that did was make the numbers a whole lot bigger. But take a closer look at the two fractions. 6x divided by 3 is 2x. And 6x divided by 2 is 3x. And it clears out the fractions. Basically, by multiplying through by 6, the common denominator, I didn't really have to deal with the fractions as much. And then the last few steps are shockingly similar to the other question, to the other method, actually. And so what I get is x equals 12. Okay? I'm not doing a sales pitch for method 2. People whose fractions aren't quite as strong are going to like method 2. And moving on to some more advanced mathematics, it's going to be nice to be able to clear fractions out. And how do we clear fractions out? Here's a great trick for dealing with fractions and equations. Multiply, I'm going to include an extra detail here, everything, multiply everything by the common denominator. It's a great way to handle these situations. It just streamlines the process a little bit. Where does that idea come from? It came from this example, method 1, where after adding those two fractions together by using a common denominator, we ended up multiplying by the common denominator anyways. Why not do it straight up front and save yourself some fraction work? So there's two more examples here where I'm going to do exactly that. I'm going to multiply everything by the common denominator. How do I know to do that? Well, this question has two different denominators. And to get rid of those denominators, I'm going to multiply through by the common denominator. Here the common denominator is 15, so I'm going to multiply 15 times everything on this side. And I multiply 15 times everything on this side. And there's some distribution stuff going on here, where that 15 has to get multiplied by everything. And when I'm doing that distribution to fractions, I'm going to want to picture the 15 as over 1, because when you're multiplying fractions, whole numbers should be thought of as fractions. So when I go numerator times numerator, on the first one I get 30x. Denominator times denominator, I get 5. And then 15x in the second one, numerator times numerator, and 1 times 3 is 3. And this side, 15 times 4 is 60. And at first glance, again, you look at this trick that I've told you, multiply everything by the common denominator, you're like, oh, that's not very helpful. All you do is make the numbers bigger. But take a look at the fractions. 30 divided by 5 is 6. 15 divided by 3 is 5. And weirdly, in this question, it simplifies down really nicely, where I don't have to do any more work after that. But every question doesn't necessarily have to do that. So that should simplify the fraction situation a lot more. Students really like that ability to clear out the fractions. And the great trick for clearing out fractions is multiply everything by the common denominator. Everything. And why do I keep making a big deal about everything? Well, check out this example here. This one can cause you a lot of trouble if you're not careful. Oh, there's a fifth example down there. I didn't see that one. Let me just move that thing down so we have a little bit of space to work there. Onto its own fresh page. There we go. And I'll go back up here. Now I've got a fresh page for each one. Okay, this big mess can scare the heck out of you because look at all that stuff going on there. And the biggest challenge here is the fractions and everything. So what I want to tell you is to clear out fractions. Say it again. Multiply everything by the common denominator. And so the common denominator here is 20, so I'm going to multiply this side of the equation by 20. And I'm going to multiply this side of the equation by 20. And I got some distribution stuff going on here. And just so you know, I'm going to picture this as over 1, but I don't have to. It's over 1 when I need it to be over 1. It's just 20. So when I multiply the 20 times the x, I don't need the over 1. I just get 20x. But when I multiply the 20 times the negative 1/4, I do need the 20 over 1. I'm going to multiply by 20 in the top. Oops. And I'm going to multiply by 1 in the bottom. And then distribute to this one. This is why I keep saying multiply everything. When I multiply 20 in the top, I got to multiply by the first term by 20, which is 40x. And I got to multiply 20 by the second term in the numerator, and I get negative 20 there. That's an often forgot step by people, is that when you're multiplying a fraction by a number, you got to multiply everything in that numerator by that number. It's a distribution thing. And then the denominators, 1 times 5, I get 5. Over here, 20 times 2 is 40. And at first glance, again, you're like, you have just made a giant mess. What an awful disaster you've created there by multiplying through by the common denominator. But take a look. 20x I can't do anything with, but 20 divided by 4 is 5. Fractions gone. Isn't it nice? The fractions are now gone. And take a look at each of these terms. 40x divided by 5, that's 8x. And negative 25 divided by 5 is 4. And by multiplying through by the common denominator, in the next step, I don't have any fractions to deal with anymore. And it becomes a question like the stuff we've been doing the last couple of days. Collect like terms over here. I get 28x minus 9 equals 40. Maybe you're a little faster at this now. You don't show all the steps. And so subtract 9 becomes add 9 when you move it over. 28x equals 49. I'm going to go over here to do the extra work to keep it all on one page. Actually, I'm going to tidy that up because I forgot something there. 28x equals 49. And then divide both sides by 28. And I get x equals 49 over 28. Watch out for questions like this. This fraction actually reduces to 7 over 4. So that's about as hard as they get. And I don't mean that to belittle them and say, oh, no big deal. Well, that's as hard as they get. That's a very difficult question. And when you get to really tough ones in the homework, and there are a couple really tough ones in the homework, come back to this one and see if you can get through them. We have no intention on tests and assignments to ask really, really crazy ones like some of the ones in the homework. But the nice thing about practicing the really crazy ones in the homework is if you can get through those, then you can get through anything that might come up on a test or an assignment, okay? Okay, back down to earth for a simpler version, something a little more reasonable. This is a question, again, that might have popped out in previous homework and might have been a big challenge. But now that we have this new trick available, I hope it's not as big a challenge to deal with fractions, because as soon as you see this, you multiply through by the common denominator. And there's only one denominator to deal with here, so I'm multiplying everything by 3. A more under control example here than that last one, just to bring it back down a little bit. And just remember, multiply through everything here. So 3 times 8 is 24. 3 times 1/3. Oh, you'll need that over 1 thing for this thing now. That's over 1. And so top times top, I get 3. Bottom times bottom, I get 3. And over here, oh, I switched colors there. That's okay. Got different colors all over the place here. 39. And so you look and go, well, that didn't clear up the fractions, but take a look. 3 divided by 3 is 1. So I get 24 plus x equals 39. One extra step there. Move the 24 over by subtracting 24 from each side, and I get x equals 15. Okay, lots of practice here, and come back and watch the videos of the specific examples that look like the ones you've been working on, because we really have to be able to deal with fractions and equations in the middle of all this. And if you haven't finished the previous 2 days' homework, maybe go back and really make sure you got that under control, because you really need all that stuff very well practiced before you start tackling equations of this level. Fair warning, there's some tough ones in the homework. Don't let them spook you. Just do your best on them and follow up with questions and try and get them landed, because those really tough ones really help prepare you for the kind of stuff that's actually in the test. So the ones that are really ugly there, don't imagine that we're going to put that scary of one on tests and assignments. Okay, have a great day.